Okay, so in this video, we are trying to convert, I should say, convert 236 to 63.3 into a floating point, a binary floating point. How would I do that? So, first you got first I would convert 263.3 into floating binary. Okay, so in order to do that, I need 260. This is the radix point. I have 263 right here, and then I will divide this by 2 and get something. So 263, here is the calculator, and you can have 263 divided by 2 is equal to 131. So you have 131 times 2 plus 1. Here the remainder is 1. That's why it's called 1. Sorry, I'm just looking at if it's recording good enough. It is recording good enough. Now after that, I have 131 is equal to 1. You get 131 divided by 2 is 65. So you get 65 times 2 plus 1, right? 65 is 0. Yep. And then you get 65, which, if my math is good, is 32. 32. Let me just make sure it's going on to YouTube. Times 2 plus 1. Then you get 32 is equal to 16 times 2 plus 0. You get 16, which is 8 times 2 plus 0. You get 8, which is 4 times 2 plus 0 again. And then at the end, you got 4, which is 2 times 2 plus 0. And then you have 2, which is equal to 1 times 2 plus 0, and then you get 1, which is 0 times 2 plus 1. So over here, when you were converting from decimal to binary, you go like from down to top, and that's why my 263 decimal into binary will be 1, then 1 2 3 zeros, 5 1 1 and 1. So this is me converting 263 into decimal. Okay, into binary, decimal into binary. Now what about 0.3? Right, 0.3 is also a trickier one. So you can say that 0.3 multiplied by 2 will give you 0.6, and then you keep track of this is 0. You keep track of this. Okay, and after that, let me just make sure I'm following up with the solution. Okay, look, I don't always look at it, but still, like, you have to look at it, uh, Okay, so now you keep track of this digit right here. Now you get 0.6 times, oh wait, wrong color. Bad, they would be. So 0.6 times 2. What does it give you? 1.2. Now you got 1.2. You keep track of 1 right here. 1. Okay, then you have 0.2, because I will not count this one times 2. Will give you what? 0.4, right? I'll keep track of this 0 right here. Then you got 0.4 times 2, which is equal to 0.8. And then I have what? 0 right here again. Then I get 0.8 times 2, which is what? 1.6, which is, which is 1. And then at the end, now here's the trickier part. I get 0.6 because I will not count this one right here. Multiplied by 2 will give you what? 1.2, which is what? Which I just consider 1. And then I get 1.2 again, which was just right there, which is 0.2 times 2, which is equal to 0.4, and that is 0. So the whole thing from here to here will repeat, and that's why I can say that this 0.3 of the decimal is equivalent to 0 1, then 0 0 1 1 0 0 1 1 da, 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 da. Okay, so that's a really easy, not easy, but meh kind of conversion. So you get 263.3 decimal will be 10000001111001100110011. Okay, just to make sure that I got it right here. If you can see, that's good. Okay, good enough. Now, now is the main point. Now, how do I? The main point is that how do I convert? There's a radix point right here. It's a decimal point. I don't want that. I want to get rid of it. How will I get rid of this decimal point? Let's see. You have to convert it into the Mentisa or whatever the binary is, and here is IEEE 754 for this. You get a signed, then you get exponent, and then you get Mentisa. Okay, now Mentisa are the for 32 bits. This starts from D22 or something like that, and yeah, this starts from D22 to D0. This is the signed bit, D33rd, no, 31, and this is the 30 to D21, if I'm not wrong. Okay, let's check the location. Now we are using the implicit one, so I will bring this guy on the right side to the most significant bit. This is my most significant bit right here, so I will bring this point to 1 2 3 4 5 6 7 8 right here. Okay, so you will have 1.1234567 8, and then you get a whole this string. I'm not gonna write it down again. I'm just gonna copy paste you, and then copy I like this and paste it here. Okay, now you get this. Now I multiply this by 2 to the 8. Okay, now I multiply this by 2 to the 8. What does it give me? uh this is what it gives me. So what do I do from here that I need to? You get, this is the signed bit. This is, so now all I know is this part right here is this part. Now then I need the sign. So since 263 is positive, is greater than 0, you get that is 0. So you have 0 for sign part, and then this part for exponential. So I'm going to copy that again for, like, I don't know, some kind of bits, but I'll see how many, 22 or something like that. But now is the exponent part. What is the exponent part? How many? Okay, 8-bit exponent part I need, right? 8-bit. Oh, it's 9. Well, I think it's 8 bits. Yeah. So since 2 to the 8, for if it's 8 bit, then you get 2 to the 8, which is 2 B 2 4 2 2 16 32 64 etc. No. B 2 4 2 2 16 32 64 128 256. Okay. It's one. Wait, what is 2 to the 8? It's 256. Okay, that's all. I'll do it.